Moving on to question 7, we've got a calculus question which starts off with a bit of algebra at the front. Verify that the coordinates of A are this, and helps use algebra to show the coordinates of B are that. So verify, we're allowed to just check this. So here we've got an equation, we can see A is an intercept point. All we're going to do for the first bit is we're going to sub in minus 2 into here and show we get 0. So we've got y equals 8 plus 4x minus 2x squared minus x cubed. Verify. Minus 2, 0. So if we've got to verify minus 2, 0, we're just going to sub in minus 2. So we get y equals 8 plus 4 lots of minus 2 minus 2 minus 2 squared minus minus 2 cubed. If we work this out, we get y equals 8. Here we get minus 8. Here we get minus 2 times minus 2 is 4, times minus 2 is minus 8. And here we get minus minus minus, so we get minus 8 times a minus is plus 8, which equals 0. It implies minus 2, 0 on curve. So we've done our little conclusion at the end and just said that this is what the bit of maths we've just done actually means. So we've verified that that is on the curve. What we need to do now is to find point B. We'll notice on here it says use algebra to show the coordinates of point B are this. We can't just verify it like we could with part A. What we do know though is that this has given us a factor. So we know that x plus 2 is a factor. So what we can do is we can use algebraic division to try and divide out this and get to our answer. So we've got, I'm actually going to write this the other way around. We've got minus x cubed minus 2x plus 4x 2x squared plus 8, and we're dividing out x plus 2. This will give us the rest, and we can factorise the rest of it and end up at the thing we want. So what goes here? We need a minus x squared in order to make our minus x cubed. So this is going to give us minus x cubed, and then we're going to have minus 2x squared. If we have minus x squared times all of this lot, we're subtracting this. Here we get 0, and here we get minus 2x minus minus 2x, which is also 0. That's quite nice. Once we get this next bit, so plus 4x plus 8, and here we've got to work out how many times this goes in. We don't have anything here now, we've just got 4 here, so plus 4, which would give us 4x plus 8. If we times this by 4, we get our 4x plus 8. Subtracting this, we get 0. So y is equal to x plus 2, and this, minus x squared plus 4. This has got us nearly all the way to finding the coordinate we need. All we need to do now is factorise this, which equals x plus 2. We can factorise this using difference of two squares. Imagine it was 4 minus x squared. This would be 2 plus x, 2 minus x. So we can see here we've got x plus 2 squared, 2 minus x, because this is exactly the same. If we look back at our diagram, we should have expected x plus 2 to be a repeated root, because the graph has touched here, which is what we ended up finding here. And our other one here is 2 minus x, so 2, 0 on curve. which is what we were asked to find using algebra. For part B, in the question, we're asked to use calculus to determine the exact coordinates of C. So C up here is this maximum point, and we need to use calculus to find this maximum. So for part B, we need to find our maximum point. We need to first find the gradient, so dy by dx equals, we get 0 from this. This gives us plus 4. This gives us minus, because it's 2 times minus 2, so minus 4x. And here we get minus 3x squared. So what we've done here is we've differentiated, and to find a turning point, we want dy by dx equals 0. So we get 0 equals 4 minus 4x minus 3x squared. We need to find the x solutions for this. So we have 3x squared plus 4x minus 4 equals 0. And we're going to factorize this. 3x and x. Now we need to make 4 here. So we need a minus 2 in here and a plus 2 in here. I think that works. Let's just check this expands correctly. We get our 3x squared, we get our 6x, we get our minus 2x, that works, and we get our minus 4. So x equals minus 2, or from this one we get 2/3. So we've got this. We just need to look quickly back at our diagram. We've got 2 turning points, one at minus 2, which is there, which is what we expected, and one over here at 2/3. So C is this point. We're asked in here to find the coordinates of C. That means we're going to have to substitute 2/3 into our equation. So we can do that using a calculator, because there's lots and lots of fractions involved here. So I'm going to go back to my thing. All I'm doing is subbing in 2/3. So I have 8 plus 4 lots of 2/3. Minus 2 lots of 2/3 squared. Minus, and then we've got our 2/3 cubed, and we press equals, and we get this number, which is 256 over 27. Again, sometimes you get nice numbers in maths, sometimes you end up with horrible numbers in maths. But here is our maximum point. So to find part C, for C we're asked to find the exact area of the finite region bounded by the curve and the x-axis. So we're after this shaded bit here. So this is the integral from a to b. The integral from an a we know to be minus 2 and b we know to be 2 of our equation, which is 8 plus 4x minus 2x squared minus x cubed dx. So here we need to integrate and find an area. So this means integrating one of these terms, then subbing in 2 and subbing in minus 2 and subtracting one from the other. So if we do our integral, we get a equals square brackets 8x plus 4x squared over 2 minus 2 lots of x cubed over 3 minus x to the 4 over 4. We're subbing in minus 2 and we're subbing in 2. So what we need to do now is 2 brackets. This one we're going to sub in 2, take away this one we're going to sub in minus 2. This is just my reminder of what I'm subbing into each one. We can do this on a calculator, you can do it by hand. I'm going to do this on a calculator because I think we're going to end up with an answer involving fractions. So we've got 8 lots of 2 plus, we can actually cancel this down now. 2 lots of 2 squared minus, we're then going to get 2/3 of 2 cubed minus 1/4 2 4. So if we plug this one in, we get 32 over 2. So 32 over 3. And then we're going to do this one as well. We can actually now alter the line we've just done if you've got one of these calculators and just stick some minuses in. This is one of the pros of doing it on a calculator. If we stick our minuses in, we get minus 32 over 2 over 3. And then if we add these two things together, we're going to end up with 64 over 3, and that's our final area.